Okay, my name is Richard, and I like dinosaurs. And I'm not even kidding, I'm literally wearing dinosaur socks right now. Another thing I like is my job. I'm a developer evangelist, and that means a couple of times a month they send up the signal over Berlin where I live, and then I go onto an airplane and I go to a cool place like New York and get to give a talk to cool people like you, or help people at a hackathon, and so on. I think this is the best job in tech, and I absolutely love it. Sometimes I get to combine those two things, because usually when I've been at a conference and it's time to go home, there's usually a few hours of time left. For example, on Thursday, my flight doesn't leave until the evening, because that's how flights across the Atlantic work. And usually I use that time to go and see some dinosaurs. For example, I was at a conference in Chicago. Guess where I went, right? They've moved to since then, which I think is shameful, and they should be ashamed, but it's a different thing. I was in Singapore once, and Singapore is really, really nice, but it's also mostly malls, and I was always wandering around, slightly bored. And then I realized they have dinosaurs. I get excited. New York is also pretty great for this, because New York has the American Museum of Natural History, which has awesome dinosaurs. And since I've last been here, they've actually put up another skeleton, the Patagotitan majorum, which is the biggest dinosaur in the world. And guess what I'm doing on Thursday before I'm flying home? And the way I usually do this is I catch rides, right? I'm actually a big public transit fan, and I got here this morning using the subway. But when you have very little time and you need to catch your flight, and you need to drop your bag at the hotel, go see dinosaurs, go back to the hotel, pick up your bag, and then get to the airport all in time, it's nice to just be able to grab into your pocket, pull out a phone, tap a few buttons, and someone comes and magically transports you to where you're going. In my case, mostly dinosaurs and airports. It really is kind of magical. Like if you think about it, the ability to just pull your phone out of your pocket and to know where you are is something we take completely for granted these days, but is actually a major technological achievement. In a way, there's now a whole generation that's grown up that doesn't even know the feeling of being lost anymore. When I was a kid, my dad used to drive us on holiday to like the south of Italy with a car. And I mean, I'm from Germany, so that kind of works out. There's roads there, just in case you're confused. But I honestly have no idea how he got us there. He must have used paper maps and magic or something. I don't know. And today we can just do that very, very easily. It's just a couple of clicks, and location technology just almost does it for us. And that's kind of what I want to look at today, like the power of location technology and what it can do for us. And catching rides, a rideshare app, is actually a pretty cool use case. This is fun. It's actually a pretty cool use case for location technology, because when you're using an app like that, that app really throws up a lot of questions that location technology is built to answer, right? So questions like, where am I? Questions like, where can I go? Questions like, what's around me? Who's around me? How can I get where I'm going? How long does that take? There's a whole bunch of these questions that come up when you're trying to catch a ride that app has to answer. And so basically what I'm going to try and do now is to go and deconstruct a ride-sharing app and look at the various elements of it and the various things it needs to do in order to get you to the dinosaurs, and look at what is the underlying location technology, how does that location technology work. Like I said, my name is Richard, I'm a developer evangelist, and I work for Here Technologies, which so happens to be the leading location technology company in the world. So hopefully I'm at least mildly qualified to talk about this. So the idea here is that this is a beginner talk for location technology. So if you can blindly place a lat long on a map, if you know exactly what a reverse geocoder does, or you have a really good idea of how isoline routing can help you find out which drivers can reach you in time, you're probably ahead of me. But if not, then hopefully at the end of this talk you will have had a pretty good overview of location technologies, of a lot of the core APIs in there, and how to use them in your own apps to build your own ride-sharing empire, or just another app with location technology in it. I work for Here Technologies. We're a company, we're all over the world, we're in 65 countries. I work in the Berlin office, and before I move on to the location technology, like if you're ever in Berlin, our office is right at the Natural History Museum. Literally my subway stop every morning where I go is called Naturkundemuseum, which is the German word for Natural History Museum. There's a life-sized Allosaurus mural at the wall, and the museum itself is really awesome. There's a real T-Rex skeleton in there, the tallest mounted dinosaur skeleton in the world, all kinds of stuff. If you're ever in Berlin, you should go. Maybe with a ride-sharing app like this. So let's assume droidCon is over. I step outside the door here, I grab into my pocket, I get out a ride-sharing app. How would that look like? Probably something like this, right? There's gonna be a map. There's gonna be like that little blue, green, whatever color dot on there to show me where I am. There's gonna be a text box where I can enter into where maybe I wanna go. There's possibly a text box there that says, hey, this is the pickup location, this is the address where you're currently at, so you can verify where you are, so the driver can find you, and you know where you are. And then maybe a button to say, hey, I actually wanna call a ride. So let's go and let's look at all of those various elements and see how they work. And we can start with that little green dot right there. That little green dot really answers the question, where am I, right? And in order to answer that question, I would use something called Positioning API, which is kind of obviously named. So an API that gets me my position. Code-wise, this is pretty simple. This is from our Android SDK. The code examples I'll be showing will mostly be from our Android SDK, from our REST APIs, though the concepts I'll be talking about generally apply, so you don't have to use us, though we're great. So what you would do here is you would simply, there's a class called Positioning Manager, and you would just get an instance of that, and then you would start that, and then you can simply ask it, hey, Positioning Manager, give me my position. In this case as a geo-coordinate, and then I can build maybe a little string to just debug that and get a latitude and a longitude. And when I do that, and when I build that location string you see there, what does that look like? If I do that in front of the door here, well, it looks like this. It basically, the string will be 40.728215, comma minus 73.958251. I actually did this in front of the door this morning, so this is the correct location of where we are. Now, in terms of an answer of where am I, that is mildly unsatisfactory because that's just two gibberish numbers that don't necessarily help me much. So let's look at what exactly that is. So when people were trying to figure out how can I actually place myself on a map, and I'm talking a long time ago, I'm talking ancient Greece, people from ancient Greece, they were thinking sort of along a grid system, kind of even the most obvious thing in the world, except of course the Earth happens to be round, which means a grid, like a rectangular grid system for coordinates doesn't work perfectly. So here's what they did. They basically drew a line around the middle of the Earth, we call that the equator, and then started drawing parallel lines to that around the Earth going up, counting up to 90, and then going down again, drawing parallel lines to the equator, going down the globe down to minus 90, just counting them with a number. And in fact, if you've ever heard the term, I don't know, the North Korean DMZ is at the 38th parallel, they're literally talking about just lines parallel to the equator. So you would just go, start at the equator, count 38 lines up, and that's where Korea is, for example. In our case, if we look at the first number here, our latitude, and that's literally what a latitude is, you count those lines, New York would be at something like 40.7. If you think about it, that kind of makes sense. Like New York is sort of, in the northern hemisphere, sort of halfway up, not quite. And for longitude, they did a slightly different but similar thing. They started drawing a line in the North Pole, going to the South Pole, and then they picked, for some reason, Greenwich, London as the place to go through. Greenwich, London is partly famous literally for the fact that this line, the prime meridian, goes through there. It's an interesting story about that. There was a conference in 1911 in the US, and lots of countries came and voted on where that line should go through, and the only country to vote against Greenwich was, for some reason, the Dominican Republic. And also the French were grumpy and abstained. kind of as you would expect. But eventually, they also went with the program. So again, if you look at that second number, I literally flew here through London, and I flew, 7-8 hours west, so I'm not quite maybe, a quarter around the world. So again, that sort of makes sense where New York would be at 4073. So if you minus 73. So if you look at those numbers, now you maybe have a rough idea of at least roughly placing them on the globe. You can sort of go up and down, and then you can go east and west, and maybe have a rough idea where a latitude and longitude is, and this kind of makes sense for New York. Now, if I were to ask you, where does that come from? Your answer would probably be GPS, right? And you'd be sort of right. The technically correct answer is actually GNSS, Global Navigation Satellite System, because that's the umbrella term for these kind of systems. And in fact, there are quite a few of these systems out there, right? There is GPS, which is the US system. There is GLONASS, which is the Russian system. There is Galileo, which is the European system. There is Beidou, which is the Chinese system. And you can already see, like, everyone in the world who kind of thinks of themselves as important wants to have one of those systems. There's also something called NAVIC, which is an Indian system, though that's technically not GNSS, because it only covers the Indian subcontinent. And the Japanese are also sending up some satellites to augment GPS to make it work better over Japan. But even then, that would not be the full answer. If you look at the code earlier, we're giving our positioning manager, when we're starting it, a location method. And it says GPS there. And in fact, you can see even we are using GPS as a generic term for GNSS in our API, even though, of course, if your phone supports Galileo and GLONASS and all these kind of things, it'll happily take that information as well. Like even my watch supports GPS, Galileo, and GLONASS. And the more satellites you can see, the more systems you have, the merrier. But there's also a network part in there. And that literally talks about things like cell phone networks and Wi-Fi networks and Bluetooth networks. Because what you can also do is, if you have a database of cell phone towers, you know where they are. If you have a database of Wi-Fi access points, and you have your phone or your device, and you can see those towers, those radio signals, you can actually go and triangulate where you are. There are advantages and disadvantages to those systems. GPS does not work well in buildings. The more concrete you have over you, the less precise GPS gets, up to the point where you just literally can't see any satellites anymore, and it just doesn't work. Try GPS in a parking garage, not happening. GPS has other problems, which in New York are particularly pronounced. Buildings get in the way, you can't see all the satellites. Satellite signals bounce off buildings, so it becomes less precise in these kind of situations. The radio network-based things still work under those conditions, but they tend to be less precise, right? You can imagine that seeing a couple of cell towers and triangulating from that is not going to give you the same precision as GPS can give you. But it has the advantage that it still works, and so that's one of the reasons you still get a location signal inside a building, even though you'll see that little circle grow much, much bigger. You might not get GPS anymore, but you will get it from cell towers and possibly Wi-Fi and so on. Okay, so now we have a latitude and a longitude. We have an idea of what that latitude and longitude actually means, and we have an idea of where we got it from. Now, the next step to answering that question, where am I, is probably to do a little more than this, because that dot by itself is pretty lonely. And the power of a latitude and longitude really lies in placing you on a map, right? So what we need to do is we need to have a map on our device in order to add that little dot. And then when we have that little dot on a map, now we actually understand as humans pretty well where we are. And again, this uses something called a Maps API, which is very imaginatively named. And adding a Maps API is not very difficult, right? Android Studio even has a default Maps activity to integrate our Android SDK. You put some files in there, change 2 lines in the manifest, and create some boilerplate code for your platform object. So I'm not actually going to show you that, because that is boring. What I do want to talk about a little bit is that making maps is actually pretty hard. Right? The world is a big place. It has a lot of detail in it, and that detail changes every day. So making maps is not only pretty difficult to begin with, it is an ongoing process. I really like this old map. This is a very old map from the, I believe, 16th century, a Dutch map that's supposed to show New Guinea. If you look at the bottom, it says in Latin, Nove Guinea forma et situs, which basically means New Guinea shape and location. And that's not how New Guinea is shaped, and it's also not where New Guinea is. I've looked at that map for quite a long time trying to figure it out, and New Guinea is actually the thing on the left side between the two red lines. The thing in the middle of the map is actually the Solomon Islands, and that big thing in the bottom is Australia. If I interpret it correctly, it's supposed to be Queensland. And you can really see the map maker struggling. Like if you look at the north side of New Guinea, he's a lot more confident about how that looks than the south side, right? There's a lot more detail. It's still all wrong, but he's a lot more confident, right? It's basically a man at work. And then you have at the bottom, Queensland he's basically just like going, there be dragons. I don't know either, right? So their location technology goes back a long time, right? So just figuring these things out, mapping things properly, just figuring out where you are based on latitude and longitude. One of those used to be fairly easy, and one of these used to be fairly hard, and I could do just a whole long challenge about latitude challenges and so on. So maybe I'll do that at some other point. Another thing to note about maps is that maps aren't always maps. These images unfortunately ended up a little fuzzy for some reason, but can you spot the difference between those two maps? That's the southern tip of South America. You've got Chile on the left, Argentina on the right. If you look at the border between those two countries at the top, you'll see that there's a fairly well-defined border on the left side, and then on the right side, there's just sort of a box that's going, I don't really know. And Chile and Argentina have a border dispute there. They literally don't agree on how the border should look like. So one of those maps is the Chilean view of it, and one of these maps is the Argentinian view of it. Now, this is mostly just boring ice fields with nothing in it, so this is not one of the more explosive border disputes in the world, but you can imagine other situations where you might even get in legal trouble for showing the wrong kind of map view in the wrong kind of country. Also, depending on the country, you might want to have things like labels set in the correct language and all these kind of things. So there's often more to displaying a map than just throwing some boilerplate code into your app and saying, please show me a map, and it looks fine where you are, right? Think about your use cases, think about where you're using your map. And then, of course, there are things like, what is the map actually used for? This is roughly, I mean, they're looking at slightly different parts of New York, but this is our map SDK in action with just a few different settings, really. And on the left, you see the map is tilted, and there's 3D buildings, and there's like a textured landmark in there. And on the right side, you have like a black map background, which is actually designed to be viewed at night, so it isn't so bright in your eyes, and really highlights public transit lines on it. And that's really just 2 or 3 lines of code difference, but a real difference in terms of the user experience. So when you're putting maps in something, consider what is actually, when is this supposed to be used, how is this supposed to be used, by whom, for what. So this is some simple code. You can see how easy it is to change these settings. So there's a set center method that basically tells you where you want the map to be, and you can animate the map while it moves over there. Then you can set a map scheme. Most maps APIs and SDKs come with a bunch of map schemes per default. This is one of them. Though you can, of course, change everything to your liking. If you want the rivers to run red with blood or the roofs of buildings to be purple, that is absolutely doable. Just make sure you keep user experience in mind. Then in this case, I've set landmarks as visible, set a zoom level, tilted the map, and because I'm not a designer, this ends up in like an unreadable monstrosity like this. Right, it's tilted, but it has also satellite imagery, which doesn't work well when tilted, and I've put landmarks on it, but also public transit lines, and then the landmarks are covering over the public transit lines, and it is completely useless. And I've ruined the wonderful map with just 3 lines of code. So at that point, it might be helpful to get a designer involved, because maps are about readability and all these kind of things as well. So designers are very useful when it comes to that. If not, just use one of the default settings. They tend to be pretty good because they've been designed by designers. Okay, let's look at the next element. So we kind of know where we are, but there's another where am I element we haven't looked at yet in the map, and this is this little text box right there. So this basically says my pickup point is at 72 Noble Street, Brooklyn, which is, I think, the address on the front door. But where do we actually get that? We have a latitude and a longitude. We don't have an address. Where do I get that from? Well, you get that from, less obviously named, a geocoder API. And what a geocoder API does is it essentially converts addresses between street addresses and latitude and longitude, or a reverse geocoder does the reverse. It converts a latitude and longitude into a street address. So the upper thing here is our front address turned into a latitude and longitude, and at the bottom is you have a latitude and longitude of where our office is in Berlin, and this is and the output is the office, is the address of where my office is if you want to send me mail. In fact, the first thing is literally something that the post office does for every single piece of package, email, whatever that goes through there. They take that address and they need to figure out where it is. So you send that address through a geocoder. In our case, we're using a reverse geocoder to take the latitude and longitude I have from the positioning API, and I'm turning that into an address I can display for the user so the user can check whether the pickup point is actually where the user thinks it is. Code for that is actually pretty simple. You see there I have a pickup defined as a geocoordinate. I put in a latitude and longitude. Then there's a reverse geocode request object that I set up, and I just feed it that coordinate. And then when I execute that with a listener, I just get a location object back, and from that location object I can literally just get the address as a string. So not particularly hard to do. Another element we still need to put on the map is the drivers, though really we've already figured out how to do this, right? Putting the drivers back on the map is simply, they also have an app that also has a positioning API, and you need to have some sort of backend, and I talked with Zan about this earlier, like how do you get all that data there? Literally just sending the latitudes and longitudes from the drivers to the end users' apps. So that we've already figured out. So the next element to look at is that text box we had at the top, where I can basically say, hey, this is where I want to go. So the address of the American Museum of Natural History is at 200 Central Park West. So I can put in 200 Central Park West. What then usually happens is something like this, right? I get this new screen or this drop-down thing which actually suggests to me a whole bunch of addresses that might fit what I've put in. And you might think now, well, in order to get the location of where I'm going, a geocoder might be helpful again, because I'm putting in an address and I want the latitude and longitude to figure out where that is on the map. The problem is the user might just want to put in a few things and you might want to get suggestions. So what you actually use is an extension of a geocoder. What you use is a geocoder autocomplete API. And what that does is it doesn't just give you one result, it gives you a list of suggestions that fit what the user has put in, right? So in this case, I've put in 200 Central Park West, and that is actually the first response you get, so that's working pretty well, but it's also going, well, maybe you meant south, or maybe you went north. And also you're in Brooklyn, there's a Central Avenue, maybe that's what you were trying to type. And if you consider how good I am at typing with the phone, that's often probably what I meant is usually the third or fourth result. I'm going to show this actually as a REST API, to highlight that all of these things are also available as REST APIs, which you can of course also call directly from your apps. You don't have to use an Android SDK if you don't want to put that into your app. So for these individual things, you can just call a REST API. And again, the interface is pretty simple here. You've got your endpoint. You need to put in some credentials. You can get that on our developer portal if you want to. And you put in a query. In this case, I've put in 200 in Central Park. I've not put in the West to make it even less clear of what I actually want. And then you put in a latitude, a longitude, and a radius, where you basically say, give me suggestions for this string at this location within that radius of 3 kilometers. And the response in JSON kind of looks like this. So you get this list of suggestions, and each of those has a label element where you can immediately see the full address, but it's also broken down into its individual parts. So from that, you can actually construct any kind of string you want to display to the user. You also see there's a match level. So that basically tells you how precise does the geocoder think this response is. In this case, he's confident that this is exactly right down to the house number. If you were to just put in USA or, I don't know, New York, it would get you a lot of results, but they would have a much lower match level. It would probably be at the state level or at the city level, right? And then you see there's the next suggestion. I've run out of space, but the next suggestion would then be label United States, etc., Central Park South. Of course, I wouldn't really put in 200 Central Park South as the address, right? What I would want to put in is I want to go to the American Museum of Natural History, right? I don't want to go to an address. Sometimes that's what I want to do, but in this case, I want to go to a place. And to find places, there's a similar API called, again, unimaginatively named, Places API, right? So that does pretty much the exact same thing, except it doesn't search for addresses, it searches for places. So if I just enter American Museum off, it would give me in New York a lot of options. Like New York is in America and also pretty big and has a lot of museums, so there's a lot of American museum offs in New York. Like again, American Museum of Natural History is the first thing it finds. There's also the American Museum of the Moving Image, the Museum of the American Gangster, which sounds kind of cool, I have to check that out, and other things as well. And again, the code for this is not particularly complicated. You set up a search request object, you feed it the string you want, then you set up a coordinate. In this case, I've named it Manhattan. Should probably be named Brooklyn because that's where I actually am. You can tell it how many results do I actually want, and then there's, again, a listener that comes with a response, and the response is a list of place links. And from those place links, I can get information, including the name of the place, but there's a lot of other stuff in there as well, right? Including ratings and phone numbers and when is it open. And then you can start doing really clever things, like in your rideshare app. If I say I want to go to the American Museum of Natural History and the ride takes 30 minutes, you could actually tell the user, hey, this thing closes in 20 minutes while you're trying to go there, right? That sort of thing. Okay, so now I have this and I found what I'm looking for and I tap on the very first thing. Then what happens? Well, what happens is usually you get a screen like this. It'll show you the route where you're supposed to go, and it'll show you information like how long is the ride, it'll give you a cost estimate, that sort of thing. And how do we do this? How do we find a route and information about a route? Again, obviously with a routing API, right? So how that looks like is, again, you set up a router object, you create a route plan, and you feed waypoints into that route plan. In this case, literally just my starting location, which I got from the positioning API, and my destination, which I got from the places API. Though, of course, I could put in other waypoints. You can put in as many waypoints as you like, right? In this case, a fairly simple thing. And then you set up, once you've set those up, once you've added the waypoints, you then go and you add options, right? In this case, I say my transport mode is supposed to be car. You could also set pedestrian, you could set public transit, you could set truck. This is actually a really powerful API that takes a lot of different parameters. If I were to set truck, for example, I could then tell it, hey, my truck is this wide, it is this high, it is this heavy, it has this many axles, this is a trailer, it's carrying explosives, and it would give you a completely different route. Because fun fact, you're not allowed to drive a truck with explosives from Manhattan. Who knew? So again, you can get in legal trouble for setting the wrong parameters on this kind of stuff, but the API supports you in getting this right. And then obviously I want to get to the dinosaurs as fast as possible, so I can set fastest. I could also set the shortest route, optimize along different parameters. Okay, and then I call calculate route with my route plan and my options, and there's a listener. And essentially then I get a route result object that can actually have multiple routes in it, because I could request alternatives. I could say like, hey, give me the 3 fastest routes, something you maybe know from mobility apps where it gives you multiple options. You can do that in one routing call. And then there's a convenient function that just allows you to add a route to the map, and it gets visualized automatically. And you can see you get from the route, you can get things like length, so it could tell you how long it would be in kilometers, but you could also get information about how long it would take to drive. Even one of those options I could have enabled would have been, please use traffic information, so I would know that there's a traffic jam and it takes 10 minutes longer. All this kind of information. In fact, if we look at how that looks as a JSON response from the REST API, kind of an excerpt from that, you get a lot of information. You get these lists of maneuvers. There's the length, there's the travel time in seconds, and you can even get instructions for each individual little step along the route. So you can get information like head west towards West Street on Noble Street, go for 79 meters. You could also set that to whatever weird system you have for measuring distances here in the US, that's fine. I just don't do that. Then I'm going to speed up a little because we had some delays, and unfortunately that's because of the setup here, it's costing us a little bit of time. So the next thing you would click on at that point is literally just that find me a driver button at the bottom. And then what would happen is the app would say something like, hey, I'm trying to find you a suitable driver. Now how does it actually do that? Well, obviously you want to find drivers that are nearby so that the driver will reach you as quickly as possible. And an easy way to do this is just look at the map, go, okay, this is where I am, I'm here at the Expo Center, and I'll just draw a circle around it at a certain distance. And all drivers that are within that circle, I can ask them maybe if they're interested in accepting the ride. You can immediately see the problem with this, right? You got two drivers here in two different spots. One of you can actually reach you quickly, the other is literally on an island on the other side of the river and will never reach you quickly, right? So what you actually want to do is, you want to use an isoline routing API. This is an advanced feature in the routing API. And what it basically does is it tells you from which places in the world somebody can reach you within, say, 10 minutes. Or alternatively, you can flip this around and say, if I were to start driving now and I have 30 minutes of time, where can I actually get in that time? And if you look at this, you'll see that there is absolutely no way anyone from Manhattan can reach us in 10 minutes from here. I mean, you already knew that, but the API, but that's not necessarily obvious in the app. Whereas even if you look at someone on the fast road, that person might even reach you even if they're outside of that circle. So that's a really powerful, cool API. You can think of lots of different use cases, delivery and so on for this. So that's a really cool kind of thing that allows you to find drivers that are actually suitable for you. And again, the API itself does not look that complicated. You put in, again, like fastest car. Traffic obviously makes sense to enable that here. You put a destination in there. Which place do you want to reach? You put a range type. In our case, we've put in time, but you could also put in distance. And in this case, I've put in 6,000 seconds, so basically anyone who can reach me in 10 minutes. Okay, so now I've actually found a rider. A rider has accepted my request. And it'll show me something like, hey, your driver will arrive in 4 minutes, and it'll show me a route on the map, right? And how does that work? Well, we've already answered that question, really. We can just get a route from the driver to you, calculate that, display that route on the map. We know where the driver is because we have a positioning API. So that is a problem we've already solved. And in fact, once the driver has picked you up, you'll probably get a very similar view, which is saying, hey, you're on your way. You'll be there in 28 minutes. This is the route we expect you to take. Again, positioning API, routing API, display this. You can get the distance from it. Now, I think I'm running out of time, so this is a discussion, this wonderful thing, why does this happen, where it's like, your driver will be with you in 3 minutes, and then it's sudden, and then you're rushing downstairs, and then it's like, no, your driver will be with you in 8 minutes, and then you're, okay, I'll go back up, I get my coffee after all, and then it's like, your driver will be with you in 2 minutes, right? For that, maybe you can visit us at the booth if you want to discuss more about this. Also, you usually get an email, and there's a map in there, and there's something called a map image API that actually lets you generate static map images you can use in a context like this. So for time reasons, we'll just go over that, but as you can see, that's pretty simple. So now we have a ride-sharing app, and I can go and I can see some dinosaurs. Also, I'm very clumsy, so hopefully they will leave me out of the country when I've left the museum. Anyway, thanks for riding with me. I know this was at best a 3-star talk, but please, you need to give me 5 stars or they'll kick me off the platform and I can't see dinosaurs on the company's dime anymore. If you want to give me a compliment or not, we have a booth out there. You can find me on Twitter, or you can go to developer.here.com, which is our developer portal, where you can find out about these APIs and a lot more. Thank you. And of course, I am very happy to take your questions.
You guys as a developer, do you guys have information about like how you guys charge for the APIs?
Yes. So we have a model we call freemium, and basically you get 250,000 transactions a month for free forever, don't even have to put in a credit card. So that's actually pretty cool. Beyond that, we'll charge you $1 per 1,000 transactions. There's also a prepaid plan where you get a discount for up to 45 cents per 1,000 transactions.
And what is considered a transaction every time you make a request to any APIs? Or?
Correct. Every time you call an API, every time you call the routing API, every time you do a request to the Places API, that will be considered one transaction. With the exception of the Maps API, this is basically tile-based, so every time you do a tile request, it counts as 1/15 of a transaction. So for map tiles, you basically get millions of those.
How do these systems know how much traffic there is? When I see a red line, it says there's a lot of traffic there. How do they know?
So that's aggregated from many different sources, including basically from apps. So we have, for example, an app called Here We Go on the App Store, which basically uses our Android SDK to build like a mobility app. And when you use that, you can opt into sharing traffic information with you. So simply imagine you're driving down a road and it's a 60-mile speed limit. And you can see there's a bunch of cars with that app driving down there using that for navigation, and they're all driving 20 miles per hour. Obviously, there's traffic. It slows down. Or if they're standing, it slows down. Then, of course, we also have relationships with municipalities who will tell us, like, hey, we're closing this road for construction, so maybe not use the routing there, and all this kind of information. So it's aggregated from a lot of different sources, but this kind of traffic probing through things like apps is an important part of it. Well, a place doesn't need to have an address necessarily. It just needs to have a location, a latitude, and a longitude, right? So if we have a place in the Places database that has a name but not an address, we still have a latitude and a longitude there. What you can do then is display the address to the user. And of course, you have a problem actually sending things like mail to that address. Though then the local postal service will probably use local knowledge to actually get you there. There are some additional addressing schemes that people are working on that are slightly different than using street addresses, sort of a mix between a geocoordinate and a more human-readable thing, but not quite a street address. Right? These are situations that you have in a lot of countries where sometimes in India the address will be, oh yeah, the building behind the flower shop, 3rd floor, or something like this. This is a real challenge for building something like a geocoder database. Requires a lot of knowledge on the ground. Fortunately, we are a big company of thousands of people all over the world, so this is a challenge we're happy to take on. Sorry, first the guy behind you had the hand up a little bit sooner.
How do you deal with poor organization? Like the dog keeps shifting around, and there are so many challenges there, right? If you're in a basement, or if it's an overcast and dogs moving around, how do you deal with those?
I mean, we can't give you a better location than the data that the positioning API gets that the positioning API you get the location from actually has, right? If it does not have GPS, we just simply can't give you a precise location. If it just sees one satellite and your location keeps jumping around, there's nothing we can do about it. What you can do for the end user experience is make sure that dot doesn't jump around that much, where you average out the recent values that you've gotten, those kind of things. That is something you can do on the user interface side to smooth out some of these troubles when they do happen.
So if, let's say you're going from point A to point B, and you're not getting a proper signal, and the roads are really close by, so does it mean that I took a longer route, or how does it work when I can transit?
So what you can do, and this is for time reasons, is an API I didn't put into the talk, but there's something called a route match API. And this basically takes a series of GPS trace, so a series of lat-long coordinates, and actually snaps that to a road. So when you are actually writing and you later want to display the route on an image in your email, you can feed the latitudes and longitudes you measured along the way, feed that into this API, and it'll actually give you back a nice clean route that snaps to the closest road nearby to where those locations were. Okay, so you had a question.
What are your thoughts on the problem of navigation within buildings?
So we have something called venue maps, which is an indoor mapping solution. So we have on that app I showed you, we have maps of shopping malls and airports and so on. We even have routing inside the building, so if you can say it, I'm here and I want to go there, it'll literally be able to show you a route through there. That even goes so far as to say, hey, I'm at home and I want to go to that store at the mall. It'll literally route you to the door of the mall and then route you through the mall up to that store. Our positioning API also supports indoor positioning, in this case by Bluetooth beacons. So if you wanted to map this space, you would go up and you would take a bunch of Bluetooth beacons, put them on the wall. Then there's a radio mapper app that you would use to walk through the venue once to kind of create a map of those radio signals. And then you can do indoor positioning based on that information. Okay? Any more questions? If not, we're happy to take them at our booth as well. Thank you so much for coming.